Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. This is the great classic group, the Bengals, singing Be With You. It's appropriate because mathematics will be with you, as will the calculus, I'm sure. Let's get to it, shall we? We'll check back in with the Bengals at the end. Simple rules of differentiation, part two. Just a few more examples I wanted to show you. And I also want to make sure that we understand different ways we can represent or a derivative or the different notation that we can use. So I'm going to list the function and then I'm going to list its derivative. Okay, and so which we have already worked with almost exclusively is if I have a function f of x, then its derivative is represented by f prime of x. If I have a function, sometimes a function is just called f because we get lazy and I just refer to it as f prime. Sometimes it's y and I refer to it as y prime. And another way, if I have y, I can refer to it as dy dx. And what that represents is the derivative of y with respect to x. All of these are ways to represent a derivative. Doesn't have to be f of x. It could be, let's get crazy, and be g of x. Well, if it's g of x, then it's just simply the derivative is g prime of x. Read the derivative of g of x, the derivative of y, the derivative of y, the derivative of f, and the derivative of f of x. All right, let's get to some examples. So, find the derivative of y, and we have this nasty looking thing. Okay, and we don't know how to take the derivative of this, but I want you to recall something, and it's rules of exponents. If I have, let's see, x to the a over x to the b, in other words, I have the same base and different exponents, or they don't even have to be different, and they have exponents, then, well, they always have exponents, but anyway, it's equal to x to the a minus b. Okay, and also if I have a plus b over c, that's equal to a over c plus b over c. So I'm going to have to do a little bit of algebra in order to take the derivative here. So I'm going to say that y equals, and I'm going to think of this as x to the fourth over x squared minus 3x cubed over x squared plus x squared over x squared. Yeah, I see you. Thank you, Handbrake. That, okay. That just shrunk down the size of the video that I just taped. So let's see, x squared over x squared, and then finally minus x over x squared. And I'm going to simplify this. Okay, let me cut this off so we don't get confused. And do you have to write this out? No. If you can do this in your head, do it in your head. So y equals x to the fourth over x squared. 4 minus 2 is 2. So this becomes x squared minus the 3 just stays. Okay. X cubed over x squared. 3 minus 2 is 1. So that's x to the first, or just plain x. X squared over x squared, same thing over the same thing, that's equal to 1. So that's plus 1. Also, 2 minus 2 is 0, and x to the 0 is equal to 1. Anything to the 0 power is equal to 1 except 0 itself. Minus, okay, this is 1 minus 2, yes, that's all right. It just becomes x to the negative 1 because 1 minus 2 is negative 1. So now, to find the derivative, I'll call it dy dx. I could have said y primed if I wanted to, remember. And then how to take the derivative. If I have a polynomial of, if the function, we'll say function here, is x to the n, then the derivative of the function, why don't we just call this f? Then its derivative, f prime, is equal to x to the n minus 1 and this n comes out front. So n times x to the n minus 1. Okay, so this 2 moves up front, and there's a 1 here. 2 times 1 is 2, x, and 2 minus 1 is 1. So 2x to the first power, which I'm not going to, well, I'll write it, but then we don't need it there. We know we don't need it there. Okay, so here, this is the first power. 1 times 3 is 3, and there's a minus out in front, so minus 3. And then 1 minus 1 is 0, right? Just following this formula. I bring n out in front and then subtract 1. Well, anything to the 0 power is 1, so that becomes 3 times 1. And now I have a constant. A constant is just a number. It has no variable. And the derivative of any constant is equal to 0. Okay? So now I have x to the negative 1. Negative 1 times a negative 1 is a positive 1. X, and then negative 1 minus 1 is a negative 2. So let's clean this up without these extra 1s and 0s. And this just becomes 2x minus 3, 3 times 1 is 3, plus 0 we're not writing, and we're not going to write that 1 in front of that x, plus x to the negative 2. So there is your derivative. So make sure you have these in your head for the rest of these examples, because we're going to be using them over and over. Next up, y equals x squared times the square root of x. Find the derivative. So we're going to find y prime. Okay, but first we're going to have to rewrite this. Okay, and again I'm going to ask you to recall that, let's see, if I have the square root, not the square root, let's say I have a, and this is x to the b, like that. Okay, that is equivalent to x to the b over a. We can write it as a fraction. Okay, so for example, right here, this is the square root of x. There's actually a 2 there. Okay, and there's a 1 right here. So I can rewrite this as x squared times x to the 1/2 power. Okay, and I still can't take the derivative of that. I don't know how to take the derivative of the product of two functions. So now I'm going to ask you to recall that x to the a times x to the b, laws of exponents, is equal to the x to the a plus b. So y is then going to equal, let me get this out of the way. If I simplify this, y equals x to the 2 plus 1/2. So y equals x to the 2.5. Now in calculus, we prefer to use fractions and not mixed numbers. So this would be x to the 2.5 written as a fraction is 5/2. So x to the 5/2. 2 times 2 is 4 plus 1 is 5. So we're going to take the derivative of x to the 5/2. So y prime equals, multiply by the exponent, so it goes out front, 5/2 x, now I have to subtract 1 here, to the 5/2 minus 1. But I'm always going to rewrite 1 using the same denominator that I have before. It just makes life so much easier. So this is minus 2/2. So this finally becomes 5/2 x to the 5/2 minus 2/2 is 3/2. Okay? So you have to remember your algebra and all of your rules. Okay, so f of x equals 3 minus x squared. Well, I need it to be a full polynomial, so I'm going to go ahead and expand that before I take the derivative. So that will be 3 minus x times 3 minus x. And if you FOIL that, that would be 9 minus, let's see, minus 3x plus x squared. And that simplifies into 9 minus 6x plus x squared. No big deal. So this is f of x. So now I'm ready to take the derivative. The derivative of f of x, the derivative of any constant is 0. I'm not even going to write it. So the derivative of negative 6x is simply negative 6 because 1, that's the exponent, multiplied by the coefficient. So 1 times negative 6 is negative 6. And then 1 minus 0, or I'm sorry, 1 minus 1 is 0, and x to the 0 is 1. So this just becomes negative 6 times 1, or negative 6. And the derivative of x squared is 2x. Move the 2 out in front. 2 minus 1 is 1, which we don't write. So we're done there. Just 2 more. Okay. Here we need another recall. And that is, if I have a over x to the b, I can rewrite that as a x to the negative b. In other words, I can move a variable up into the numerator if I make the exponent negative. So that's what I'm going to do here with g of x. Okay, that equals 2. And I don't know how to take the derivative if this is in the denominator, so I need to move it up to the numerator. So that's going to be x to the negative 3. The 5 stays because it's not being raised to the third power. So the 5 stays in the denominator. Okay, minus 3x. So to take the derivative, I take, let me rewrite that. I think it'll be a little easier for you if I rewrite that real quick. And I'm going to say that's equivalent to 2/5 x to the negative 3, which I know you know, but it just makes it easier if we're looking straight at it like that. So the derivative is going to equal negative 3 times 2/5 x. And what's negative 3 minus 1? That's going to be negative 4. And the derivative of negative 3x is negative 3 because there's a 1 here. 1 times negative 3 is negative 3. 1 minus 1 is 0. X to the 0 is 1. And negative 3 times the 1 is negative 3. So we just have to clean this up now. Negative 3 times 2/5 is negative 6/5. X to the negative 4 minus 3. So we're done with that one, and then we have one final one to do. Find the derivative of this. So I'm definitely going to have to expand this before I take the derivative. So I'll take this x and multiply it through here, and then we'll multiply by this, the result. So x times x is x squared, and x times negative 1 is negative x. And then I have to multiply that by 2x plus 4. Okay. A lot of folks say, well, don't you have to take the x through this too? Well, no. If you had 3 times 4 times 5, you would say that's equal to 12 times 5. You wouldn't say that's equal to 3 times 4 and then 3 times 5 again. So that's the same reasoning here. So x squared times 2x is 2x cubed. X squared times 4 is 4x squared. Negative x times 2x is negative 2x squared. And then, let's see, negative x times 4 is negative 4x. And let's simplify that. We have like terms here, so this is going to be 2x cubed plus 2x squared minus 4x. So that's what y equals. So then the derivative is equal, and I'll just write this as y prime. 3 times 2 is 6. X, 3 minus 1 is 2, 2 times 2 is 4, so that's 4, x, 2 minus 1 is 1, so that's the first power, and then 1 times negative 4 is negative 4, and that would be x to the 0, because 1 minus 1 is 0, so that is our derivative. Alright, that's all I have. Hope you enjoy it. Let's see how the Bengals are doing. They want to be with you, as does the calculus. I am out.